Okay, so we took BCA, which is in hex, and we're trying to find binary, we're trying to find octal, and trying to find, not dex, but decimal. Let's write that properly. And basically all we did was we took the A, converted it to binary, 1010, which is 10, 1100, which is 12, and 1011, which is 11. So that gives us BCA. So now that we've got the binary, it's really the same for octal and decimal. Well, really the same for octal as what we did a while ago. So if we divide it into groups of 3, we're going to write 0, 1, 0, 1, 0, 0, 1, 1, 1, and then 1, 0, 1. All right? Yep. Got 3 groups, 4, now we have 4 groups of 3. So 0, 1, 0, 1, 0, 0, 1, 1, 1, 1, 0, 0. Yep, that works out. Okay. Could be me now. So 2, 1, 7, 5. So we've got our binary already. It's right here. We've got our octal. It's 5, 7, 1, 2. And then we've got to get our decimal, and it's just a matter of adding up the digits and changing this to a 1, 2, 4, 8, 16, 32, 64, 128, I'm running out of room, 512, 1,024, 4,096, 8,192. Whee! So I'm going to let somebody with a calculator do that for me, but we basically are adding up, and I'll do the numbers, 8192 plus 1024 plus 512 plus 128 plus 64 plus 8 plus 2.
9930.
9930. 9930. So we work backwards. So now let's take an octal and do the same thing that we just did. Everybody got how we did that? Right, we'll go back through it. Going once. Going twice. And sold. Okay. So happy I have my whiteboard back. It's like a long lost friend. All right, let's do 2, 6, 7, 4 octal. And we want binary. We want decimal. We want hex. I'll give you a minute to work through that one independently, and then we'll do it together. So we know that's octal. How many are going to be in each group? 3 for the binary. 3. I'm going to be working on 2. may have math wrong, so if you're looking at mine and it doesn't seem right. I'll do it first, it means I was doing the best of it I did. Has anybody got the same thing yet? Or still working? I'm gonna rework it again just to make sure, so I'm getting some looks, so how do you get that?
Anybody else get 1468? Anybody else get a
That's the one I got
010 in front
1468?
instead of a 10?
Yeah, that can't be right, 'cause I can tell right now. I think I shifted over, I moved my numbers around a little bit while ago. So let's disregard the decimal for the moment. I'm gonna redo mine, make it right.
I don't like a binary either.
Don't like my binary?
No, show me how you got that 101 in the front instead of 010.
Yeah, cause I got 010.
All right, let's work through this one. Looks like I have done a good job of goofing it up. We're gonna go back to 2674, right? Again, I'll do the first and do it all again. All right, 2 is 1, 0. Let me write that a little bigger so I don't have to cram these numbers in. 1, 0. And again, I'm doing in groups of 3, right? So it's applied 0, 1, 0. 6 is 0, 1, 1. I mean, 1, 1, 0. So 1, 1, 0. 7 would be 1, 1, 1. And 4 would be 0, 1, 0, 0. So again, go back to our groupings of 3. That goes to here, that goes to here, that goes to here, and that goes to here. So we got binary, octal to binary at least. So now I'm gonna write my values where I know I screwed up while ago. I'm gonna do 1, 2, 4, 8, 16, 32, 64, 128, 256, 5, 12, and 1,024. So 1,024 and 256 are 1,280, 1,380, 1,388, 1,408, 1,440, 1,456, 1,464, 1,468 decimal. Yay.
So, I got a question.
All right, sure.
Why can't we go all the way to 248 on the, after the, okay, 1024?
We can, there's just nothing there, there's no place. We only have a 1, 2, 4, 8, 16, 32, 64, 128, 256, 5, 12, 1,024. Now, if we wrote a 0 there, that would really be the 2,048 position, but there's just nothing,
Okay,
yeah, there's nothing there.
oh, okay.
So, all right, so we've got binary. There it is. And now hex it's just a matter of going every 4. So I'm gonna draw that imaginary line. 1, 2, 3, 4. So, that's 8 and 4, which is 12, which is what? C. 1 and 2, which is 3 plus 8, that's 11. B. And then, 1 and 4. So at least I did get the, hexadecimal equivalent right while ago. So as the old saying goes, even a blind squirrel finds a nut every once in a while.
Squirrel?
Sorry, Kelly. That is triggered right there. So 5 BC, which was a long time. So we'll do one more just to nail it in. We'll go back to hexadecimal. Because I've always really wanted to know, your hexadecimal number is A, B, C, D. That's hex. So we want binary, octal, and we want decimal. A, B, C, D, hex. I'm gonna make me a cheat sheet so I won't screw up. Oh, Cheryl got that look like, man, he just. Nonetheless, don't let it against the keyboard tray. Y'all see an error in my math, especially if y'all come out with the same answer as mine. All right. Yeah, I found the number converter. Y'all can't use this on the test, huh?
Someone's done it on 3.
One, two, five, seven,
That's what I'm looking at.
That's all.
The one on the us. That's what I'm looking at.
you got it. I just,
Says my auto was wrong.
You can copy the wrong numbers.
Did I copy?
125.
All right, so apparently copied the number wrong. Somebody said 1, 2, 3. So it should have been 101. 010 instead of 101 right there, right? Yep.
Either one on one.
I was a little dyslexic there. Ergo, this becomes a 2. A whole lot easier when you kind of see it in a small sheet of paper.
there's a reason the first three letters in the text does not text.
I still think you're missing a set.
Ah.
This is still wrong.
Page 4-1.
01.
Oh, yeah, I did. Yeah, I blew it big time. It really is hard to tell. I'm not kidding. All right, let's try this again. All right, 1, 2, 3. That's 1, 0, 1. 1, 0, 0. Right here. And 1, 1, 1. That's right here. And 1, 0, 1. Yeah, I missed it big time. And then 0, 1, 0. And then a 1. Yay.
Yeah.
Yep, screwed up big time. I should have told you the rest. So that's 4, 2, 1, and that's a 1. So 5, 1, 7, 5, 2, 1. Is that more better? Yay. My English teacher will be proud. You know how to get the right answer really fast. post the wrong answer.
Really?
If you want somebody to give you the right answer or something, just post the wrong answer. You'll have as many people tell you how wrong you are if you do the right. Little known fact. All right, so let's talk about how we got there, and how I didn't get there. But first, to get the binary, I just took and broke it up into groups of 4. It's hex. So D, and I wrote me a little chart over here, is equal to 13. So my first group of 4 has got to equal 13. 8 and 4 is 12, plus 1 is 13. C is equal to 12, so 8 and 4 are 12, and nothing here. And I had to get 11 for B, which is 8, 2 and 1, 8, and then I had to get 10, 8 and 2. So that's how I got my binary equivalent, was just simply taking that hex, grouping it into 4 sections, making the last 4 equal D, which is 13, then 12, then 11, then 10. So boom, got my binary numbers up there. Octal, after omitting tenths, had to take those same 4 groupings and put them in 3 groupings. So taking these same numbers, and instead of writing them in 1, 0, 1, 1, I had to go 101, 1, 0, 0, 1, 1, 1, 1, 0, 1, and then 0, 1, 0, and then 1, and then just getting the decimal equivalent of those groupings of 3 to get octal. And of course, decimal, just a matter of going back up here and adding my places under binary, 1, 2, 4, 8, 16, 32, 64, all the way out to, holy cow, he gave us a number that had 32,768. So again, just a matter of mathing it through the process. So I think we're starting to get a good handle on this. If not, like I say, we do have some remediation periods out there. And the awareness that really in the long run is going to be much more important than doing the math, but it really wouldn't hurt you. In fact, one of the things that I took that got me hired at Rockwell 185 years ago was they gave us a little test, and it happened to have some octal and some binary and some things like that on it, and I was able to answer some of those questions. Fortunately, I had just went through digital electronics at that time, so it was perfect timing as far as that goes. So you never know when it might come in handy, but mostly having an awareness that we can represent binary in other forms, such as hexadecimal and decimal and octal, will also come in handy, especially when you start looking at PLCs down the line. All right. And again, it's just going back to the fact that in hexadecimal, we group in groups of 4. So we take that string of binary numbers, starting at the rightmost side, group them into 4 subsections, do the 8421, 8421, and go into the next step. And there we go, 1Z4. So, and remember, have that little chart, or remember at least that 9 equals 9, 10 equals A, 11 equals B, all the way up to 15, because hexadecimal, which is 16. Hex with decimal, for lack of a better term, hex and meaning 6 and decimal meaning 10, so hexadecimal equals 16. So just like when we talk about the 10 system, we only go through 0 through 9. When we talk about the hexadecimal, we only go through 0 through F. There isn't a number 16 per se, we have to shift columns. All right, so there you go. The binary number 110011111111 converted to its hexadecimal equivalent. First one with the right answer has the right answer.
Hey.
I didn't even group it out for you. So you can narrow one out just by doing the first 4 there. So it's either B or C. And I can do it after doing the second section. Lay it on. Number 2, E7B. That's right. In fact, you can do just,
You can do the first one on the right side and you get it.
there you go. Exactly. And that's a math, that's a quiz taking, tip there. It was narrowing down what it is, and sometimes it's just as important as understanding what it is, at least as far as taking quizzes. So yeah, we went ahead and did this, 8, there's nothing before, so 8, that's 11. So if we convert 11, 9 is 9, 10 is A, 11 is B. The answer has to end with B. There's only one answer that ends with B, and that's the middle one. But if we keep going, 4, 2, and 1 equals 7, 8, 4, and 2 is 13, and if we find the letter of A, it's 10, 11, 12, 13. There we go. So we get E7B.
Shouldn't that be D?
Ooh.
It's D. That's what I was thinking when I done it out, I was like, it wasn't right, but that should be a D.
8 plus 4 plus 2, that's 14. I said it wrong, I think. Yeah, it is E. If I said 13, that was my fault. But 8 plus 4 plus 2 would be 14, which is one shy of F, which is 15, which gives us E. And that is another thing, and NIDA is not 100% infallible either. We have some situations where
You will spend too much time arguing with NIDA. You know you're right, NIDA says you're wrong, just go with it.
But question everything, but, you know, understand why you're wrong or why NIDA's wrong. All right, so we used the reverse process. Obviously, we just did a lunch of them. We took F, we converted it to its 4 groupings, which is 8, 4, 2, 1, which gives 15, 9, which is 8 and 1, which is 9, and C, which is 12, which is 8 and 4. So again, using those same groupings, kind of already beat to death. All right, what is the decimal equivalent of 8 F9C and the binary number 111100111100? So it goes ahead and groups it for you in binary. Of course, that really just shows you the grouping. We still got to do the math. But if we go along, 1, 2, 4, 8, 16, 32, 64, 128. 6, 5, 12, 1,000, 24, 4,096. So I already know that one. 2,048. So we know the next one's 4,096. So we know these 4 numbers are getting us, you know, this is basically 1, 2, 4, 8, 16, 32, 64, 128, 2, 6, 5, 12, 1,024, 2,048. Even if we do some rough math, 2,048 plus 1,024 is 3,000, plus 512 is about 3,500. I know that one without finishing it out, simply because we're already greater than 273. There's certainly no way to get 14,000. But if we add all those up, we should arrive at 3,996, which is the right answer. Again, process of elimination. Practice time. All right, call them out. Convert the octal number 100 to its binary equivalent. 100. So how do we convert it? Throwing you a little curveball because it's 100, but it's in octal.
Ah,
So 0, 0, 1, 0, 0, 0, 0, 0, 0. They tried to make your brain think it was a binary number, but it's not. 1, 2, 4, 8, 16, 32, 64. Actually, I just converted it to binary. I'm going to decimal now. So sorry about that. I tried to make it trickier than it was. So the answer is what? C, right? Okay. Convert the hexadecimal. Oh, they're doing it again. Bless our little hearts. The hexadecimal number 100 to its binary equivalent. All right, so what do I write for the first groupings of 4? Yep, technically 0, 0, 0, 1. That's my first grouping, because it's octal. And then I've got to have my next grouping of 4. I mean, it's that hexadecimal. Then I have my next grouping, 0, 0, 0, 0. Then my next grouping. So again, trying to trick our little brains. How dare NIDA do that to us? But if that number had been 215 in hexadecimal, you went, okay. But because it was 100, your first instinct was, oh, that's a binary number. No, it's still an octal, a hexadecimal number. But you got to do it in groups of 4. So I can't really count zeros, but I think it's probably the first one, just based on the sheer number. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Yep, it's the first one. Everybody get that? They tricked us. Had that been the number 4, well, let's write. Let's see. I would have been asking for